All right, welcome back. It's section 7.3. We're going to talk about complex numbers. And so you'll recall last chapter you were asked often to solve quadratic equations. The first choice was always to factor, if it was possible, and then if it was not factorable, such as the one up on the screen, we went to the quadratic formula. So I have it set up where I plugged in A, B, and C to the quadratic formula, and I got to this as my answer. All right. Before today, you would write, because there's a negative under the square root, that there is no real solution and you would stop there. And so today what we're going to do is we're going to find those solutions, and they will be complex numbers. All right, so here we go. We're going to start out by talking about the square root of -4, and has a name for it. Anytime there's a negative under a square root, we call that an imaginary number. And up until today, we would just stop and say, can't do it. And starting right now, we're going to be able to simplify the square root of -4. All right, so it's based on what we call the imaginary unit. And the imaginary unit is the letter I, lowercase I, and it is equal to the square root of -1. It's like a definition, so you don't have to worry about why, just know that it is. All right, so if I is equal to the square root of -1, we can now look at the square root of -4 and break it up into the product of two square roots. All right. The first is going to be -1 and the second one will be 4. Well, we've just said that the square root of -1 is I, and everyone knows that the square root of 4 is 2, and so we can now continue. Instead of stopping at the square root of -4, we can find the answer, which is 2I. All right. We can also do simplifying negatives under a square root. So here's another example, and then we'll do a lot of practice of this in class. What about if I have -50 under a square root? Well, that's equal to the -1 and then times the square root of 50, and we remember the square root of 50 as the square root of 25 times the square root of 2, and so my final answer is 5I square roots of 2. All right, hopefully that makes sense, because now we're moving on to these things called complex numbers. And complex numbers are just the numbers we come up with when we put together imaginary and real numbers. So a complex number will have be of the form A plus BI, where A is the real part and BI is the imaginary part. All right, so an example of a complex number would be 2 plus 3I. Okay, so complex numbers are those numbers with a real and an imaginary part. Okay, so now what we want to do is we want to bring in some arithmetic and talk about what happens when we add, subtract, and multiply imaginary and complex numbers. All right, so I have some problems on the screen. Adding is super simple. All you need to remember is that you can only add real to real and imaginary to imaginary. So 2 plus 3I plus 7 minus 6I would be as easy as 9, 2 plus 7, minus 3I minus 6I. All right. With subtraction, it's also very easy as long as you remember to distribute that negative sign. And so 8 minus 5 is 3, and -6 minus 2 is -8I. And then we're done. Multiplying starts out pretty easy with the distributive property. We multiply the 3 by the 2 and we get 6, 3 by the 7I and we get plus 21I. Okay, things get a little dicey when we're asked to double distribute, or what we like to call is FOIL. So I have two complex numbers here, and I'm going to multiply them together by finding the 4 products. So watch me. I'm going to multiply 7 times -2. Good. Outside times outside is -7I. That's 7 times -I. Inside, negative times a negative is a positive 8I, and then the last times the last, -4I times -I, is a positive 4I, and this is really important. I times I is I squared. All right, so we need to clean this up, so we're of course going to add the middle terms together, but we've never before, when we talked about complex numbers, we said we always have to be in the form A plus BI. So we need to do something about 4I squared. So we're going to find out what I squared is equal to. All right, so if I is equal to the square root of negative 1, then if I square that, the square root of negative 1 times the square root of negative 1 would be negative 1. So here's the deal. Anytime you end with an I squared in your answer, you may not leave that. You must change that to 4 times negative 1. All right, so final answer here, negative 14 minus, negative 7 and 8 is plus I, 1I, and then minus 4, so last final answer is negative 18 plus I. Okay? Perfect. All right, so that's addition, subtraction, and multiplication. Let's talk a little bit about, my time. Let's talk a little bit about that problem we started out with. You recall x squared plus 2x plus 2 equals 0. We ended up with negative 2 plus or minus square root of negative 4 over 2. And so let's go ahead and, I apologize, my Microsoft OneNote keeps crashing, so I'm going to try to continue this. Let's see, where was I? Oh, I didn't quite finish this. So this was negative, there it goes again. Okay, we'll try this one more time. Hopefully it will let me get to the end of this video. I'm almost there. So you recall at the beginning we had a quadratic that we needed to solve, and at the beginning we stopped here and said no real solution. So let's go ahead and finish it with what we know now about imaginary and complex numbers. So we can rewrite this as negative 2 plus or minus 2I over 2. And so then we can simplify it because there is a factor of 2 in all of them, and we'll go ahead and call that negative 1 plus or minus I. So what exactly does this mean? If we were to take negative 1 plus I and put it into the original quadratic,